Hello and welcome. My name is Alexander Barr and I'm a research scientist with Amiga Sciences, part of ICL. I run trials to assess new products that are currently being developed, as well as benchmarking our products that are currently on the market against other competitor products. Today I'm going to be talking to you about H2Gro wetting agent, specifically how H2Gro works and what technologies have been included in the product. I'm then going to go on to talk to you about some trials that have been completed this year, as well as a trial that's currently going on around me. So to set the scene, I'm going to start off with growing media. It's an incredible thing, its ability to absorb such a huge amount of water in relation to its original weight, and its ability to then provide that water back to the plant throughout the day. However, I'm sure I don't need to tell you the issues that it can have. It's uneven water distribution after wetting. This can result in pockets of dry media, and that's because water follows the path of least resistance. So these are the problems that the chemists have been working incredibly hard to solve and why they've produced H2Gro. And here we have the team of chemists behind H2Gro. They've been working over decades to produce H2Gro. They've included a multitude of surfactant technologies to produce H2Gro. It's specifically designed to wet media quicker, for longer, and more thoroughly. Now, before I can talk to you about H2Gro and how it works, I need to talk to you very briefly about the properties of water. Water is made up of H2O, and it's a very special liquid, obviously essential for life on Earth. The reason it's so special is it's a polar molecule. You have a slightly positively charged area on the hydrogen atoms and a slightly negatively charged area on the oxygen atoms. And you get hydrogen bonds forming between these molecules. They're not strong bonds, but within a glass of water there'll be billions and billions of them. Here's a diagram representing those hydrogen bonds between the water molecules. They won't normally form this lattice structure. They'll be flowing over one another, breaking and reforming all the time. Now what happens at the surface of the water is slightly different. The water molecules are unable to form hydrogen bonds with water above them, because there isn't. It's just air. So what happens is they form extra hydrogen bonds with the water molecules around them. This produces surface tension, and that's what enables this pond skater to skate across the surface of a pond. It's also what enables Tim Peake to play ping pong with a large droplet of water in the International Space Station, because those hydrogen bonds are maintaining the integrity of that droplet. So what happens with droplets here on Earth? Well, here we've got one which I've stained blue for you so you can see it clearly. What I'm going to do is take a toothpick and I'm going to try and break it. Nothing really happens. But if I dip this cocktail stick in a surfactant and then make contact with the water droplet, you can see that it loses that surface tension and begins running down the page. And that's because that surface tension has been reduced so much that it loses that integrity and spreads over a large area. And that's obviously really good within a media setting, because it allows that water to spread throughout the media. So how does it do it? Let's have a look at the surfactant molecule in more detail. You have a hydrophilic head and a hydrophobic tail. The hydrophilic head sits within the water droplet. The hydrophobic tail protrudes out of the water droplet. And that process interrupts those hydrogen bonds we spoke of earlier, and that's the cause for the reduction in surface tension. There's something else going on here as well, which enables water to spread throughout media more evenly. If you imagine a glass of water and you pouring some sunflower oil into the glass, the fat and the water isn't going to mix. And that's because you've got polar water and hydrophobic oil. Soap is a surfactant. So if you added soap to that mixture and mixed it up, then you'd get that dispersion of the oil and the mixing of the two products. It's exactly the same in media. Organic matter within media is hydrophobic. So having these hydrophobic tails sticking out of the water molecule enables an interaction that allows the water to spread over those previously hydrophobic molecules, enabling the spreading of the water throughout hydrophobic medium. We have here three groups of surfactants: non-ionic, anionic, and cationic. The anionic got a negatively charged hydrophilic end. The cationic has a positively charged hydrophilic end. The non-ionic doesn't have a charge to it. And it's the non-ionic surfactants that we use. It's for a multitude of reasons, but predominantly it's because they don't have a phytotoxic effect at the rates that we prescribe. Within those groups of surfactants, you've got a large amount of variation due to changes in shape, size, and structure. And that causes variations in the properties of those surfactants. What the chemists at Amiga have done is managed to integrate these three agents within the one product, H2Gro. The spreading and penetrating agents enable the water to get into the media and spread throughout. Not only that, but it enables the spreading of the re-wetting agents. These are large block copolymer molecules. They remain in the soil or the media for a long period of time, enabling that re-wetting process. I'm now going to do a demonstration of just how effective H2Gro is at enabling a media to uptake water. So, I've got some plain water here. I'm going to pour it on. And as you can see, there hasn't been much uptake of the water. It's sort of run off the surface of the media and is just pooling at the bottom there, not being absorbed. I'm now going to apply some water which has been treated with H2Gro. You can see that as I apply it, almost immediately you start getting the water being uptaken at the surface of the media. And then you see this vast ingress of water. So you get an increase in water uptake rate, but you also get more thorough wetting of the media. I'm not going to be talking to you today about how to use H2Gro, how to apply it. My colleague Stephen Chapman will go through that in another session later on. I'm going to focus on a trial that was recently completed in Germany and then go on to talk about the trial that's currently going on around me. The trial was carried out in Wilhelmshaven in Germany and 3 treatments were applied. We had the control of water, H2Gro and the closest competitor on the market. They were applied at 50, 100 and 150 ml per meter cubed. The application method was incorporation. The experiment consisted of 10 dry days. That's where the peat is completely dried to 0 and re-wetted before being dried down to 0 10 times. The wetting method was by submerging the pots, the bottom 2.5 centimeters, into water for 10 minutes. Now the pots had this window which enabled the trials officers to observe how far the water moved up the pot. And these are the results here. We've got the 2 products, H2Gro and the competitor. The control along the x-axis of 0. So all the results are in relation to that. So pretty much all the results were better than water alone. There was one statistically significant result that H2Gro saw an increase in how far the water moved up through the media in comparison to all the other treatments. That was when H2Gro was applied at 150 ml per meter cubed. This graph shows the volume of water that was absorbed by the media. As you can see, when H2Gro was applied at 100 and 150 ml, there was an increase in the volume of water absorbed when compared to the competitor product. The statistically significant result was again at 150 ml per metre cubed, where more water was absorbed. There was no decrease in performance of any of the products over the course of the 10 dry down period. H2Gro is specifically formulated for potting soil manufacturers, and this trial was run at an accelerated rate, the dry downs being run at 25 degrees every hour for the 24-hour period. This led to the NIAB trial being run sort of as close to grower practice as possible. So let's have a look at the NIAB trial. Here we have a trial which, on the surface of it, looks incredibly boring. But in fact, we're producing a huge amount of data which we can analyse and take forward. We've got 33 treatments, each repeated 6 times, so we've got 198 pots. Each pot is assessed every day, so we're producing 198 pieces of data every day. And this trial is being run for 7 months. This is producing a huge amount of data, enabling us to assess the performance of H2Gro against the competitors that are currently out there on the market. So here we have the data on a graph for the first 2 dry downs. I do need to explain that this is provisional data and statistical analysis has not been carried out. On the y-axis, we have the percentage change of mass. So at the bottom, here on the 0%, that's the weight of the mass when it was dry. After the wetting event, you see this large increase in mass. And that's because the water is being absorbed by the media. All of these results are for H2Gro when applied at different rates. And you can see there's a really strong correlation between the application rate and the amount of water absorbed. You may notice that there's an application rate of 200 millilitres per metre cubed being tested in this experiment. Our recommended highest rate is 150 millilitres per metre cubed. But we included the higher rate as competitor products were recommending a 200 milliliter per metre cubed rate. So we needed to include it for the comparison. The rate of 200 millilitres per metre cubed sees the highest weight increase and therefore the absorption of most water. This is followed by the 150 ml, then the 100 and then the 50 ml application. Finally, the lowest weight that was absorbed was by the control, water. The second dry down showed similar results, showing a continuity of performance. On the second graph, we're using the same axes and see similar results. And finally, on this last graph, we include competitor products. They're all applied at the same rate, and you can see that H2Gro outperforms all the other products.
Firstly, thank you, Alex. That was a brilliant presentation. Lots of technical information packed in there. I'm Steve Chapman, Technical Area Sales Manager for the South East of England. I'm going to be taking you through some practical scenarios of how you can use H2Gro on your nursery, and I hope you'll find them useful. I thought I'd start at the beginning of production with what is a very common scenario and a problem that many of you will face throughout the year. As you can see here, I have a tray of agapanthus. Some of them are very dry and some of them are also very wet. This can present some big problems when these get potted up, as the growing media they are in can be so dry that they will be unable to take up the water when they are watered after potting. This can leave the young plants dry and stressed at a time when they're at the most vulnerable, and could lead to the plants dying or the beginning of a root disease as the roots die back. And if nothing else, this could lead to some of the plants getting away quicker than others. It is most likely that these would have been fed at the young plant producer with a water-soluble fertiliser. This will not last long enough for them to root out and into the new growing media to access the new feed. This is a great time to give the plugs some feed with a water-soluble fertiliser, such as Peter's Plant Starter. With its 10-52-10 analysis, it gives the plants the optimum start to life, and with its super low conductivity is safe. By combining H2Gro with Peter's Professional Plant Starter, Not only will you help bridge the gap in nutrition, but you will also be enabling the plug to be fully wetted up with no hydrophobic areas. This means it will be able to absorb the water surrounding it from the growing media in the weeks and months ahead as it starts to root out, giving these plants the best possible start to life. This is a very common scene on the UK nursery, where you'll be having multiple crops on a single bed with one irrigation. This can lead to the edges of the bed drying out. This is the south side of a plant. As you can see, there is no root on this side compared to the other side. This will be because of the dryness from this side of the pot. By adding H2Gro into a dosatron and applying it along the edge of a bed, you can help stop the drying out on the edge, so that when the irrigation eventually comes on, it will fully wet up all of the growing media. Another brilliant use for H2Gro liquid is when you have a batch of plants that are bigger than those around them. When trying to correct this, it can leave you with lengthy periods on a hosepipe while the growing media absorbs water again. As if you don't, when the irrigation next turns on, the plants that are smaller and still wet will start absorbing the water straight away, whereas the plants that are dry will take some time to start soaking up the water. Whilst it is not absorbing the water, it will be running off and being wasted. But by adding H2Gro liquid into a dosatron, or in smaller areas, even a watering can, you can treat the batches that are using more water. This will not only help with the wetting up the next time the irrigation comes on with its long-lasting formula, but its penetrating action will help speed up the watering when trying to get them wet again. This is another brilliant use for H2Gro liquid, when the plants are taller than those that are around them. This is another common situation you'll be faced with on a nursery. These plants here are feeling the full effect of all the sun and the wind, whilst the ones that are further in will not be. By applying H2Gro along this edge, you'll be able to mitigate the need to top these plants up with a hose pipe. This is another prime example of how the edge effects are making the plants on the outside of the bed wilt, and yet the ones in the middle are perfectly fine. For more information about H2Gro, please contact your ICL Technical Area Sales Manager or your distributor.